Good morning.
Good morning.
Is my voice audible?
Yes, ma'am.
Is there any background noise? Background noise is
No.
there? No, no, okay. Let me share my screen. Can you all see the screen?
Yes, ma'am.
Yes, no. So we were in the last live class, we were discussing about basic operational concepts. In that, we were discussing about this figure, right? The connection between processor and the memory, right? So this is mainly required to understand how an instruction gets executed by the processor. Okay, so you have a memory, main memory, RAM, and then a processor, central processing unit. And central processing unit will have control unit, arithmetic and logical unit, then PC. These are all registers. Okay, these are all registers. What is PC? Anyone? Rakshit, what is PC? Rakshit,
Program counter.
yeah, PC is program counter. IR, Neha, what is IR? Neha, are you there? Aaron Joy, Aaron Joy, what is IR? Bhargavi, Bhargavi, what is IR?
Instruction register.
Instruction register. So instruction register is used to hold the instruction which is to be executed, right? Program counter holds the address of the instruction to be executed. Okay, then what is MAR? MAR stands for memory address register. Memory address register. To fetch any instruction or operand from the memory, the address of its corresponding memory location has to be present in the MAR. Okay, so it is called as memory address register, which holds the address of the data present in the memory. So data can be either the program instruction or the operands. Okay, MDR stands for memory data register. Okay, memory data register holds the data which is sent to the memory for storing in the addressed location, or the data which is read from the memory, okay, into the processor for the execution. Okay, processor, right? Data transfer from memory to the processor is called as read operation. Data transfer from processor, okay, to the memory is called as write operation. Storing the data is write. Accessing the data from the memory, that is read operation. Okay, so read and write. Processor to memory data transfer is write. That is after execution, you will be storing the data into memory. So you are sending from processor to memory. Okay, to perform an execution, you are reading the data from the memory. It can be the instruction you are reading, program instruction you are reading from the, you means the processor reads from the memory, or the operands which are read from the memory for the execution by the processor. That is called as read. Okay, so be clear about read and write. Okay, or read is also called as load operation, memory to processor. Okay, date load, okay. And write is also called as store operation, that is processor to memory, storing the data. Okay, so be clear about MAR and MDR. MAR holds the address of the particular location of the memory. Okay, so that particular location can either have the instruction or the operands. Okay, so to access instructions and operand, the corresponding memory address has to be present in the MAR. First, the address is sent and the data from the corresponding location is placed into MDR. Okay, so then all these operations, memory read, memory write, all these operations are controlled by, and even the instruction decoding is also controlled by control register, and it will send the control signals for different operations performed by the processor as per which the processor performs the instructions. Okay, so what kind of bus is this which is connected to memory address register? Anyone? What kind of bus is this? There are three buses. Address bus. What kind of bus is this?
Address bus, ma'am.
Yeah. Okay. The second one,
Data bus.
Data bus.
data bus, and the third one is control bus. Okay.
Control.
So address is sent via address bus. Data transfer between memory and the processor takes place via data bus, and read, write, control signals are sent to the memory by using control bus. Now, by taking the same explanation, I'll go through. Okay, I have explained the concept with the help of a figure. The explanation of this, I'll read it quickly one by one, the steps, okay, as a summary, okay, as a summary. So basic operational concepts. Processor contains number of registers used for different purposes. Instruction register, IR, holds the instructions that is currently being executed. Program counter, PC, keeps track of the execution of a program. It contains the memory address of the next instruction to be fetched and executed. During the execution of an instruction, the contents of the program counter are updated to correspond to the address of the next instruction to be executed. So what does it mean? Program counter contains the memory address of the next instruction to be fetched and executed. During the execution of an instruction, contents of the program counter are updated to correspond to the address of the next instruction to be executed. That means, initially, assume that the first instruction in the program is fetched. To fetch that, program counter should have that instruction's address, and from the program counter it will go to MAR, and then from the address to location the instruction is placed into MDR, and from MDR the instruction is transferred to instruction register. This is instruction fetch. The next task is instruction decode and execution. Now, before decoding and executing the instruction which is present in IR, program counter will get incremented to hold the address of the next instruction in the memory. Okay, so we call that program counter holds the address of the next instruction to be executed. That is because the previously fetched instruction which is present in IR is yet to be decoded and executed. So meanwhile, soon after fetching the first instruction, the program counter is updated in between. It will not wait for the previous instruction to complete its execution. Okay, so that is why even before the previous instruction is executed, the program counter would have been incremented and it will have the address of the next instruction in the memory. So once program counter is incremented to hold the address of the next instruction, the previous instruction gets decoded and then executed, and after execution the next task is to execute the next instruction, and whose address is already present in the program counter. So directly the fetch operation will take place from the address which is present in the program counter. So again, the program counter address is loaded into MAR, and then the instruction from the corresponding location is placed into MDR, and from MDR to IR. Okay, the second instruction fetch is completed. Okay, the next task is to decode and execute the instruction. Okay, before that we have program counter which gets executed soon after the instruction fetch, right? So program counter again gets updated to the next instructions address, that is the third instructions address. So address from the program counter is updated and it is sent to MER, and from MER the memory will receive the address, and the instruction present in the third location is transferred to MDR. Okay, like that, understood? Even before the previous instruction gets decoded and executed, the program counter would have been pointing to the next instruction in the memory. That is why we say that the program counter contains memory address of the next instruction to be fetched and executed. During the execution of an instruction, that means the current instruction, the contents of the program counter are updated to correspond to the address of the next instruction to be executed. Did you understand the program counter concept? And same thing was explained in this animation, which I had told you to watch soon after the previous live class, right? Are you clear about the concept of program counter and instruction register? It was very clear in this video. Anyone, please? Is it fine?
Yes, ma'am.
Okay. So if anyone has still doubt, you can inform me later, because I have spent enough time in this actually. I'm repeatedly telling you these things because the entire syllabus is based on this. These are the very basic things which you should be very clear. Later on, you will not be able to understand if you are not thorough with this. I can call a private meeting, okay, one-to-one meeting. Also, I can call and I can explain you once again if anyone has doubt. Okay, I can call a Google Meet if you tell me if you have not understood still. Okay, I'll proceed. So it is customary to say that program counter points to the next instruction that is to be fetched from the memory. Okay. So you know that R0 to Rn minus 1, which are there in that figure. Okay, these are the general purpose registers. Two registers facilitate communication with memory, and those are MAR and MDR. MAR is memory address register, holds the address of the location to be accessed, right? It holds the address of the memory location to be accessed. MDR is memory data register, contains data to be written into or read out of the addressed location, right? MDR, you have a bidirectional data bus connecting MDR to the processor, right? It contains the data which is either read from the memory or data which is returned to the memory. So it contains the data to be written into or read out of the addressed location. So now the steps one by one. Programs reside in the memory and usually get there through the input units, right? Program counter is set to point to the first instruction of the program. Program counter is set to point means program counter is loaded with the first instruction's address in the program. So if the program counter has a particular location's address, then we say that program counter is pointing to that location. That is the way to explain that. Okay, if the program counter is having an address of particular memory location, it is customary to say that program counter is pointing to that location. The contents of the program counter are transferred to MAR and read signal is sent to the main memory. As soon as the contents of the program counter are transferred to memory address register, read signal is sent to the main memory. The addressed word is read out of the main memory and loaded into MDR. Okay. As soon as the memory receives read signal, the addressed word, the word which is present in the addressed location, is read out of the main memory and loaded into memory data register in the processor. The contents of the memory data register are transferred to instruction register, right? The contents of the MDR is nothing but the instruction now, right? Instruction is fetched and that is transferred to instruction register. The instruction is ready to be decoded and executed. As soon as the instruction is transferred from MDR to instruction register, Instruction fetch phase is complete. Next is decoding and executing. Okay. So during execution, the contents of the program counter are incremented or updated to point to the next instruction. Okay. So while the previous instruction is getting executed, that is decoding and executing together, the program counter contents are also incremented to point to the next instruction. That is what I told, right, in the program counter part. If the instruction involves an operation to be performed by ALU, for example, if the instruction is add or and, right, which has some arithmetic and logical operations, okay. So if the instruction involves an operation to be performed by arithmetic and logical unit, it is necessary to obtain the required operands. Now, where will be the operands? If the operand resides in the memory, it has to be fetched by sending its address to MAR again. So this will be the second read cycle. First the instruction was fetched. Now while decoding, if there is any operand which resides in the memory, it has to be again fetched by the same process. Its address has to be sent to MAR, and then a control unit initiates a read cycle. When the operand has been read from the memory into MDR, it is transferred from MDR to ALU. Since it is an operand, now the data transfer from MDR to ALU, not to the instruction register. Operand has to be transferred from MDR to ALU for the operation to be performed. After one or more operands are fetched in this way, if there is one more operand also, the second operand also resides in the memory, again the third read cycle has to be initiated by sending the address of the operand again to MER, and from the address location the data or the operand is placed into MDR, and from MDR the second operand again goes to ALU. Once the ALU gets the required number of operands as per specified in the instruction, it performs the desired operation. For example, if the operation is add operation, addition takes place. Add will be the control signal generated by the control unit, okay, after decoding the instruction. So ALU can perform the desired operation by taking the operands and also the control signal which tells it what to do with the operands, whether it is add, subtract, whatever it is. And that control signal is generated due to decoding with the help of the control unit. Okay. So a flow chart which tells you fetch, decode and execute steps of an instruction. So start of a cycle, address in the program counter is copied to MER first. Then program counter increments to point to the next instruction. Instruction found at address described by MER is copied to MDR. Instruction is in MDR copied to IR. Control unit decodes the contents of the IR. Control unit sends the signals to ALU. Okay, so these many operations come under fetch. That is, from placing the address of the instruction into program counter till transferring the data from MDR to IR completes the fetch cycle, and then decoding part includes decoding of the instruction present in the instruction register by the control unit, and execution, it is performed by sending the control signals to ALU. So as soon as ALU receives the control signals from control unit and then the operands, it will perform the execution. So I repeat, start of a cycle. First, address in the program counter is copied to memory address register. Program counter increments to point to the next instruction. Instruction found at address described by MER is copied to memory data register. Instruction in the memory data register is copied to instruction register. Then this completes fetch cycle. Then under decode, control unit decodes the contents of the instruction register. Then under execution, control unit sends the signals to ALU. Okay. Now, we discussed till performing the required operation, till the execution. Now, after the execution, assume that this okay, uh, add LOCA, R0 was the instruction which was fetched from the memory, and then while decoding, the instruction register comes to know that there is one operand in the memory location LOCA. So second read cycle is initiated by sending the address LOCA to MER, and from the address to location, from this location, the data is placed into MDR, and from MDR, the data will go to ALU. Okay. Now ALU receives the ALU has received the operand present in the memory, and one more operand it will take from the register directly. There is no separate read cycle because registers are inside the processor. Okay, it will take directly from R0, second operand, and control unit sends a control signal add. During decoding, okay, control unit generates add control signal that is also received by ALU. So ALU receives two operands and also the control signal add. It performs addition of these two operands, and then the result will be there, right? After the addition, the result will be there. Now, if you want the result to be stored in the memory, if the next instruction in the program is something like store LOCA, that means store the result of the previous operation into some memory location LOCA. So then what has to be done? Okay. So result of an arithmetic and logical operation is present in the ALU. Actually, there will be one register called as accumulator register, which is not shown here pictorially. Okay. So accumulator will be a register which holds the result of arithmetic and logical operation. Now, it cannot retain there because that is temporary. If there is one more operation which takes place, the contents of accumulator will be overwritten. So it is the customary to transfer the result to the memory for the storage, right? So how to transfer? We have discussed about reading the instruction, reading the operand which is present in the memory location, and performing the arithmetic and logical operation, that is execution of an instruction. The fetching, decoding, and execution we have discussed. Now, if you have to store the result in the memory, what operation will take place? So that will be the memory write operation. You are sending the data of an operation or data after execution to the memory. So whatever data you are sending to the memory or receiving into the memory, it has to be first placed into MDR. If you are receiving the data from the memory, it is received into MDR. If you are sending something into the memory, it has to be first placed in MDR. From MDR only it will go to memory. So you have a result in the accumulator register, or in the ALU also you can say, because accumulator is a part of arithmetic and logical unit. You have a result of an operation in ALU. From ALU, the result or the sum is transferred to MDR, and the address into which the sum has to be stored is transferred to MER. Now, MER will have the address of the memory location into which you want to store this particular result. Okay, so the result of an operation is in MDR. Okay, or the data which has to be placed in the memory location is there in MDR. MER holds the address of the location in which this data has to be placed, and then control signal will generate a memory write operation. Okay, so control unit will generate a memory write signal, and that is sent to memory. So in the control bus you have a memory write signal, okay, which is transferred to memory. MDR has a data which is sent to the memory to the data bus. MER has the address of the memory location into which this data has to be stored. Okay, so as soon as the memory receives the address and the data and the write control signal, the data from MDR is placed into corresponding addressed location. That completes the instruction fetch, accessing the operands, and storing the result in the memory. So both memory read and memory write operations are involved. Okay, did you understand Anyone has any doubt here?
No, ma'am.
Okay, the last part I will summarize. If the result of this operation is to be stored in the memory, then the result is sent to MDR. Okay, the address of the location where the result is to be stored is sent to MAR, and a write cycle is initiated. The contents of the program counter are incremented so that the program counter points to the next instruction to be executed. This is already done in between, right? As soon as the instruction was fetched, program counter was incremented, right? So this doesn't come here. This is already discussed. As soon as the instruction is fetched, the program counter is incremented. See here. See, during the execution, the contents of the program counter are incremented or updated to point to the next instruction. It happens in between itself. So, this is repeated here. This actually doesn't happen at the end. This happens in between. So, once an entire operation is completed, the next instruction is fetched from the address which is already there in PC. So, please exclude this part here. Thus, as soon as the execution of the current instruction is completed, a new instruction fetch may be started from the address which is already there in the program counter. Now, this particular process can be explained with the help of an animation. This particular animation is from one of the college which is called as Hartismere College of United Kingdom. So, I will just show you that, which will give you step-by-step animation of each the operation. Okay, and then we'll work out two examples. Okay, I will give you the instruction. You have to give me the steps. Okay, from the beginning till the end, till storing the result of an instruction as per the instruction given. Can you see the screen?
Yes, ma'am.
Fetch, decode, execute cycle. Okay. So here, this part is CPU. Okay, accumulator, arithmetic and logical unit. I have said you while explaining the previous figure. Accumulator is a register which holds the address of the result of arithmetic and logical operation. It is a part of the ALU itself. Okay, here it is shown externally. It is can be shown as inside ALU. Okay, so then you have registers here: program counter, memory address register, memory data register, and CIR. CIR in our textbook figure we have it as just IR, instruction register. Okay, computer instruction register or just instruction register. Okay, then the control unit. Okay, so all these units are part of central processing unit or processor, and then this is the memory. Okay, this is the memory. So connection between processor and the memory, and this is a bus which is connected between different functional units. So here a common bus is shown because here you can see three specifications. They have told red is an address bus, green is a data bus, blue is a control bus. So these three dots will indicate that at a time how this bus is utilized, whether this is utilized as address bus or data bus or control bus. Okay, so by this particular dots, you have to understand that this is the data which is getting transferred from the data bus, or address which is getting transferred by using address bus. The connecting path is commonly shown as black, but you have here different indicators to show address, data, and control, which you will understand when I run this. So you have a memory here. So 1, 2, 3, 4, these are the memory location addresses. Okay, address of the memory location 1, 2, 3. Okay, and this is the data which is present in the memory location. So what you have here, load 5 is an instruction at memory location 1. Add 6 is an instruction present at the memory location 2. STO7, that means store 7. Okay, STO7 is an instruction present at memory address 3. Okay, then there is nothing in the memory location 4. In the memory location 5, or the location with the address 5, we have operand. Okay, 12. And at address 6, you have one more operand, 8. Then at the address 7, you don't have anything. So all these are addresses of corresponding locations, and this is the data present in each location. Data means the contents of that particular location. Okay, data means in general, it is a data means the content what is present in that particular location. So in the location 1, 2, 3, you have instructions stored, and in the same memory at the location 5 and 6, you have data, or the operands stored. Operands stored. Understood? Understood. Say in the same memory we have both instructions as well as operands. Now, what is the first step? To fetch the program or the instructions from the memory. Assume that this is the first instruction of the program. Address of that has to be present in the program counter, right? To fetch any instruction, its address has to be present in the program counter, which is already there, right? Program counter will have the address of the first instruction in the program by default. Understood? It is already there. Program counter holds the address of the first instruction, 1. Then I'll start. What is the next task, anyone? What is the next step? Anyone can tell me? What is the next step? Program counter is already having the address of the first instruction to be executed. That is load 5. What is the next step? Anyone?
It is sent to memory address
correct.
register.
So this address is sent to memory address register. So I'll run. Okay. So from here it is sent to MER. Then after that,
MDR.
not MDR. This,
Memory.
It's sent to the memory.
this address has to be sent to the memory through the address bus, right? Through the address bus. And then the data present in that location, that is, what is the data present in that location? Instruction load 5 has to be sent to MDR through the data bus. Right? As soon as the memory receives the address, this address 1 is sent through the address bus to the memory. At the same time, read cycle has to be initiated by the control unit. So control unit will generate a read cycle, which is indicated by a blue line. As soon as the reads signal is received and the address is received by the memory, memory will place the data present in that location, that is load 5, into data bus, that is a blue colored bus, and that will be placed in MDR. Just see this. So address is flowing to memory along with the control signal, that is read signal. Okay. So memory has received both address as well as read signal, indicating that it is a memory read operation. The data present there is load 5. This is the instruction which has to be transferred to MDR. Okay, what is the next step? Address is sent, read signal is sent, data at that location is load 5 instruction, that is sent by the memory to MDR. through the data bus. So it is indicated by green. Then what is the next step? MDR has the instruction now. What is the next step?
It is sent to instruction register.
It is sent to instruction register. Okay. Now this completes instruction fetch. Next task is instruction decoding and execution. Before that, something will happen. What?
Increment of basic.
Yeah,
Increment.
correct. That's correct. So program counter is incremented to the next instruction's address. Okay. So then we have decoding and execution remaining of the previous instruction. So run. MAR gets. Now what happened here is decoding is taking place. Okay. So instruction is present in load instruction register. Control unit is responsible for decoding this. So while decoding, what does it mean? Load 5 means what? Load the contents of memory location 5. Okay. So instruction is getting decoded, and while decoding, it will come to know that the operation is load the data from memory location 5. Okay, memory location 5 is this, and the data is 12. Load 5 means load the data from the memory location 5 into the processor. So now the address, memory location's address has to be sent to MAR. This is the second read operation. During the execution, if there is any operand present in the memory location, has to be read into processor, right? Now during the decoding, it will understand that the operation is load the content from the memory location 5. So the address of the memory location is this one, right? 5 is the address of the memory location. So to load that from the memory, content of memory location 5 from the memory, again the address of the memory location has to be sent to MAR, that is sent. And then read cycle has to be, the second read cycle has to be initiated by the control unit, right? Address along with the read signal will flow to the memory. Understood? Address of the operand is placed in MAR. From MAR, the address via address bus will flow to the memory, and the control unit will generate a second read signal. Now what will happen? What is the data present in memory location 5?
12.
12. Okay. So what is happening now? Decoding is done. Now execution is taking place. While decoding, it understood that there is some operand to be placed from the, loaded from the location 5. So address is sent to MAR, and then read signal is initiated. The address from MAR is transferred to memory via address bus, and you have a read signal sent to memory. Now the execution, loading the data from the memory location 5. So 12 is a data present in memory location 5 that has to be copied into which one? Memory will place this into data bus, and from data bus it will flow to MDR, correct. So you have a yellow color indicating that the data is getting transferred from the memory. Data at memory location 5 is 12, and that is placed into MDR. Now data is the operand is fetched. Operand present in this particular instruction is fetched. Now what is the next operation? From MDR, where it has to go? It will go to ALU. Okay, from MDR it will go to ALU. So it will go to accumulator of the ALU. That completes the execution of the first instruction. Data from the memory location 5, that is 12, is loaded into accumulator, into the processor, and the processor means it will go to arithmetic and logical unit. So now the next instruction fetch, from where it is fetched? From the address which is already present in the program counter, right? Program counter would have been already updated to the address of the next instruction, right? So run. Second instruction fetch is taking place now. Address is already there in the program counter. Address is 2. From program counter, it will go to MAR. Same process. From MAR, it will go to memory along with the read operation, read cycle from the control unit. Then the instruction present in the memory location 2, that is the data of that location or content of that location, is placed into data bus and it will flow to where?
MDR.
MDR. Okay. From MDR, since it is the instruction, it will go to instruction register. Instruction register. Now fetch, second instruction fetch is completed. Next is decoding and executing. Before that, program counter should be updated to have the next instruction address, right? So that is done, controlled by the control unit. Okay, program counter is incremented. So now decoding of this. So this instruction is add 6. Add 6 means add the contents, okay, from the memory location with the address 6, okay, to the contents already there in the accumulator or ALU. Okay. So to add we need 2 operands, right? For addition we need 2 operands. Here in the instruction only 1 operand is specified. Add 6 means add the contents to the contents of the memory location with the address 6. So this particular operand 8, which is present in the memory location with the address 6, has to be added to the contents which are already there in the accumulator. So one more operand it will take from the accumulator, one more from the memory. So this is already there in the accumulator. So during decoding, it will understand that what has to be done, right? So addition has to be performed, addition of the operand from the memory location 6 with the operand in the accumulator. So the operand from the memory has to be fetched here. So address from the instruction register, address of the operand from the instruction register has to go to read. To read the operand from the memory location 6, its address which is present in instruction register has to go to anyone. Same thing how we did the previous instruction. Memory address register. Memory address register will get the address of the operand. From MAR, the address will flow to memory along with the control signal which is read. Along with the control signal which is read. Now, the operand, right, 8 from the addressed location is placed into data bus and it is transferred to MDR. From MDR, where it will go?
Accumulator.
Yeah, accumulator. Since it is operand, it will go to accumulator. Now, second instruction, execution is not yet completed. It has just transferred, right? The operation is add, right? Operation is add. Just the second operand is loaded. Now, further continue the operation. Arithmetic and logical unit will receive the add control signal from the control unit, which is not indicated here, but okay. So arithmetic and logical unit adds 2 operands and you have the result in the accumulator. This completes the execution of the second instruction. It has added the contents which was present in the processor with the content of the memory location 6. Execution of the second instruction is completed. Now third instruction has to be fetched. To fetch the third instruction, it is the address of the instruction is already present in the program counter. From program counter, the address of the instruction has to go to MAR, right? From MAR, along with the read signal, the address will flow to memory. Okay. The instruction at that location is STO7, that is transferred to MDR through the address bus. From MDR, it is placed into instruction register. So the instruction fetch is completed. Before decoding and executing this, program counter will be updated to the next instruction. That is, next instruction address is 4, right? 4 is the address of the next instruction. So program counter is updated. Now we have to decode the previous instruction. Okay. So for decoding, what does it mean? Store 7 means store the result present in accumulator into memory location with the address 7. Store 7. As you know, store is the data transfer from processor to the memory. So this is the address of the memory location into which the data has to be stored, right? So you have a data in the processor that has to be transferred to the memory location 7. Okay. So I'll run this animation. What will happen here is the address which is present in this instruction is 7 is transferred to MER. Now to store something in memory location 7, memory has to receive the address 7, right, from MER, and then the data which has to be placed in this location, that is from the accumulator, right? So memory cannot receive directly the data from the accumulator. The data which has to be transferred to the memory has to be first brought into MDR, right? Data which has to be transferred into memory has to be brought into MDR, and address has to be present in MER, and then a write cycle has to be initiated by the control unit. All these 3 signals has to be received. A write signal, okay, from the control unit, that is indicated by blue, and then data has to be previously present in MDR. So from accumulator, data has to be brought into MDR first, and from then MDR it will flow to memory, and for into which location it has to be stored, that address also has to be provided to the memory from MER. So now what happened here is decoding taking place. While decoding, there processor understands that there is some memory location address, so that address has to be placed into MER later to send it to memory. Then the data which has to be stored there is brought into MDR, and then both data and the address along with the write signal from the control unit are sent to memory, and then the result is placed in the addressed memory location. Understood? Did you all understand?
Yes, ma'am.
Okay. So go through it once again. Anyway, I will be sending you the PPT today. This link is there in the PPT. Okay, exactly same as the steps we discussed, okay, with respect to that figure, and also the steps are mentioned in the presentation PPT. If you have understood that, you will be able to follow. What you have to do is you have to press this button, okay, soon after every operation taking place. So that's the end. Again, it is reset to the first instruction address is present in the program counter. Okay. So again, when you press, it will start from program counter to MER, MER to memory along with the read signal, and storing the data, loading the data from that location. That is load 5 instruction into MDR, from MDR to IR, then increment the program counter, then decode the previous instruction. While decoding, if there is any operand present in the memory location, the address of the memory location is again transferred to MER to read that operand. From MER, along with the read signal, it will flow to memory, and that particular operand is placed in the data bus, and it will flow to MDR. From MDR, it will flow to arithmetic and logical unit. That completes the first instruction's execution. Second is add 6. So program counter will already have that particular address. From there, the second instruction is fetched, and then it is decoded, and after decoding, the required operation is performed. Then fetch the third instruction. So you have 3 instructions here in the program. Load the contents of memory location 5, add the contents to the memory location 6, and store the result in the memory location 7. Okay, so I will close this class, and please understand Okay, go through it because this is required till the end of the semester, these concepts. Okay, so you have to understand clearly what is MER, MDR, instruction register, program counter, control unit, ALU, memory concepts, and how the instruction gets executed. Okay, the sequential steps, one after the other. Okay, step by step, how it is happening. And then two instructions we will work out. I will give you two instructions. So here with this animation, three instructions are worked out here, right? So I will give you one instruction or two instructions. You have to tell me steps, okay, with respect to this figure. Okay, by keeping in mind this figure, you have to tell me what will happen step by step. Okay, fine. You have any problem with the classes? How it is going on? Recorded class, live class? Any feedback you want to give? You can either the class reps can collectively give me the comments or the feedback. You want something to be improved or you want any help or anything. Okay, so if anyone has not understood, you can contact me and I can have a one-to-one session. Okay, instead of addressing all students together, so which cannot be done in the regular class, I can have a separate session with you if you still have doubt. So please go through the presentation, please go through both the animated videos, the one which was sent in the previous class and today's class. Okay, previous class animation which I had sent is to understand how the instruction register and the program counter works. It is only fetch. Okay, there we discuss only the instruction fetch. How soon after fetching a instruction, program counter will be increment to the next instruction even before the previous instruction is decoded and executed. That you will understand in the YouTube video, and today's animation you will understand the complete fetch, decode, execute, okay, with the help of a complete program where there are three instructions in the program, how the instruction is fetched and required operands are fetched and how the result is stored. There were three instructions. One was to load the operand, second one to add arithmetic and logical operation, third one to store. The program included all the operations which can be performed with the processor and the memory. Memory read, memory write operations were also involved. So that gives you, today's animation gives you a complete understanding of different operations performed during the execution of an instruction. Okay. Anything to say? Anyone? We are going very slow, okay? We have not even completed half of the module 1 because since these concepts are very important and required till the end of the semester, I'm spending more time. Repeatedly, I'm explaining you the concepts, okay, which I'll not be doing later on. So if you have any doubts, you have to clear here itself, okay? So don't stay with the doubts because later you will not be able to understand. Okay. Shall I call the attendance if nothing is there from your side? Yes? Purti Rai?
Present, ma'am.
Aaron?
Present, ma'am.
Adnan?
Yes, ma'am.
Ahisam?
Yes, ma'am.
Aishwarya?
Present, ma'am.
Akanksha?
Present, ma'am.
Akash Voyam?
Present, ma'am.
Aksha?
Present, ma'am.
Aldino?
Present, ma'am.
Amrit? Amrita
Present,
Nayak?
ma'am.
Amulya?
Present, ma'am. Present.
Ananya?
Present, ma'am.
Anvit?
Present, ma'am.
Apurva?
Present, ma'am.
Aaron Joy? Arlia?
Present, ma'am.
Arul,
Present, ma'am.
Ashita,
Present, ma'am.
Ashna,
Present, ma'am.
Ashwini,
Present, ma'am.
Ashwit,
Present, ma'am.
Atul,
Present, ma'am.
Atul Gopal,
Present, ma'am.
Bhargavi,
Present, ma'am.
Bhavish,
Present, ma'am. Present.
Brian,
Present.
Brijesh, Chandana,
Present, ma'am.
Present, ma'am.
Darshan,
Present, ma'am.
Deepak, Dion.
Present, ma'am.
Present, ma'am.
Those who have given the attendance can leave the class, okay? Danya,
Present, ma'am.
Emmanuel, Emmanuel, Guru Prasad,
Present, ma'am.
Hanson, 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 Ishika,
Present, ma'am.
Jess,
Present, ma'am.
Jason,
Present, ma'am.
Jitesh,
Present, ma'am.
Jenisha,
Present, ma'am.
Jofi, Joslia, Joslia, Jyotika,
Present, ma'am.
Tanmay,
Present.
Karthik,
Present, ma'am.
Karthik Kesi,
Present, ma'am.
Kirti,
Present, ma'am.
Danvin,
Present, ma'am.
Boyd,
Present, ma'am.
Loknath,
Present, ma'am.
Bhavit,
Present, ma'am.
Anvita,
Present, ma'am.
Megha, Megha, Meghana,
Present, ma'am.
Meghana R,
Present, ma'am.
Milton, Nisika,
Present, ma'am.
Muhammad Tahir,
Present, ma'am.
Isha,
Present, ma'am.
Muhammad Kef,
Present, ma'am.
Namrita,
Present, ma'am.
Navya,
Present, ma'am.
Neha, Neha, okay. Nivedita,
Present, ma'am.
Pooja,
Present, ma'am.
Pranam,
Present, ma'am.
Prithviraj,
Present, ma'am.
Kritika,
Present, ma'am.
Rahul,
Yes, ma'am.
Rakshit,
Present, ma'am.
Rakshit Mogavira,
Yes, ma'am.
Ryan,
Present, ma'am.
Rishabh,
Yes, ma'am.
Robin, Sachin,
Present, ma'am.
Sai Prasad,
Yes, ma'am.
Samiksha,
Present, ma'am.
Samrudh,
Present, ma'am.
Samyak,
Present, ma'am.
Sandesh,
Present, ma'am.
Sandhya Holla,
Present, ma'am.
Sannidhi,
Present, ma'am.
Santosh,
Yes, ma'am.
Satvik Shetty,
Present, ma'am.
Satvik Amin,
Yes, ma'am.
Syed Arshad,
Present, ma'am.
Shalom,
Present, ma'am.
Carol,
Present, ma'am.
Charvari, Shodhan,
Yes, ma'am.
Present, ma'am.
Srinidhi,
Present, ma'am.
Shreya,
Present, ma'am.
Shreyas,
Present, ma'am.
Srihari,
Yes, ma'am.
Tefia,
Present, ma'am.
Suhan,
Present, ma'am.
Sukit,
Present, ma'am.
Sumiti, Sushan,
Yes, ma'am. Present.
Sumiti is absent.
It's Sumit, ma'am. By the way, he's absent.
It is Sumit. Okay, other day in the attendance I had made correction. Sumit is absent. Huh? Who is his friend? He was absent for the last class also. Who is Sumit's friend? Who is the class representative?
Yeah,
Class
ma'am. See.
representative. Huh? Hello.
Yes, ma'am.
Who is this?
Rahul.
Rahul, just tell this Sumit to contact me, okay?
Okay.
Rahul and Pooja, no? Class representatives?
Yeah.
Okay. Because he was absent for the last class also. Sushan,
Yes, ma'am. Present.
Swastik,
Present, ma'am.
Swati,
Present, ma'am.
Ashwin,
Present, ma'am.
Tejasvi,
Present, ma'am.
Varsha,
Present, ma'am.
Varshini,
Present, ma'am.
Vignesh,
Yes, ma'am.
Vignesh Pai,
Present, ma'am.
Vijesh,
Present, ma'am.
Vishnu,
Present, ma'am.
okay, you all can leave the class. And one more thing, class representatives, please remember to remind me to record the live class, okay? Sometimes I don't remember to record. So it will be a problem if some people have connectivity issues and they are not able to be connected all the time. So they can see the recorded class later. So if it is not recorded, it will be a problem. So if I don't start recording, you will come to know that, right? So please remind me if I don't record in the beginning. Okay, you can remind me. Okay, you can please unmute and tell me to record the class. Please take this responsibility. Thank you.
Ma'am, can you upload today's recorded video?
Yeah. I will upload, and all the
Okay.
previous ones also.
Okay.
Thank you. Yeah.